Okay, today what we're going to talk about is how to make scientific, fact-based, specific observations. So we've looked back at the airplane experiment and we've figured out what our dependent variable is, our independent variable, our controlled variable, and now we're ready to conduct the science experiment. So I know you've been super excited. So what you're going to need is you are going to need your notebook, okay, your science notebook, a tape measure or your ruler from your box, a pencil, your whiteboard and marker, and your airplanes. Okay, so pause this video and go grab those items. All right, so now that you have all of your items, what are you going to do? Well, you're going to document what you observe. So you might be thinking, okay, well, how am I going to do that? I'm just going to eyeball it and go, it flew across the room? No. Are you going to make a guess? I threw the airplanes and the smallest one went the furthest. Done. Nope. Just hold on and let's talk about how you're going to do your science experiment with your airplanes. So when we talk about observations, right? Observations must be specific. You need to use complete sentences and give only the facts. So, an example would be, it flew to the couch. Okay, well, that's not very specific. How far did it fly? Like, where did it land? Did it touch the ground first or did it skid across the floor and stop at the couch? Like, those are the things that you need to think about. And you need to write it in a complete sentence. Your observations have to be scientific. That means you must use a science tool to document your findings, like a ruler, a tape measure, magnifying glass, thermometer, scale. That's just to name a couple things that you need to use in order to make it a scientific experiment. You are experimenting, trying to prove what is going to work better or how to improve how something already works. It has to be measurable, okay? The experiment has to be able to measure, meaning show the differences between one thing or another. You're not going to say like, this paper airplane was folded this way and this paper airplane was folded that way. And I think plane A is going to go the furthest. Well, that's not going to work either. They need to be exactly the same, maybe just different sizes, but everything else has to be the same. And your data, your observations, must be quantitative. Can you explain the data from your experiment? You have to. So what that means is you have to prove what you observed. Okay? So example, if you write down the distance each airplane flies each time it's flown, you can prove that. Right? So go ahead and take a screenshot of this page. And we are actually going to add some examples and non-examples of what observations look like. So here we have scientific observations, and here we have unscientific observations. For instance, the turtle has a mass of 8 kilograms. That is a scientific observation. If I put it on the scale, if you put it on the scale, my husband puts it on the scale, it is going to weigh the same. The leaves on the tree began turning brown on October 12th, 2022. That's a fact. Okay. What happened? The leaves on the tree began turning brown. The average length of the leaves on the tree is 5 centimeters. Did I measure every single leaf on the tree? No. But I took measurements of several leaves, and the average was 5 centimeters. Are there going to be smaller and bigger ones? Yes, but most of them are going to be 5 centimeters. There are fewer hours of daylight today than 30 days ago. Is that observable? Yes. Can you prove it? Yes. Now let's look at the unscientific observations. The shell is shiny and pretty. That's an opinion. This room seems colder than it was last week. Okay, that's an opinion too. The tree looks weird. Opinion. The bottle is heavy. Opinion. You have to prove that. If you said the bottle weighed 1 pound, that's a fact, but not it's heavy or pretty or colder or shiny or weird. Those are unscientific observations. So, you're about ready to collect your data, okay? You need to find a place in your house, all right, preferably inside, okay, because you don't want wind, the outside air or the wind to have a factor in how far an airplane can fly. So pick somewhere in your house that's open, that wherever it lands, you're going to be able to measure how far it flew. You're going to need to throw every airplane each time at the same spot. So I'm going to stand right here and I'm going to throw my airplane. Then you're going to throw the airplane and you're going to take your tape measure or your ruler and you are going to measure how far it flew from where you're standing to the tip of the airplane. And then write it down in your notebook, okay, and number them. Paper airplane A, okay, flew 4 feet, 4 feet, 3 feet, 1 inch, 2 feet, 7 inches, okay, number them. Paper airplane A, all right, and then each time that it was flown and how far. Paper airplane B, you're going to do the same thing. C, D, how many ever airplanes you made. You are going to do the same procedure for each airplane you created. You're going to use the same ruler or tape measure as you did the first time. And you want to write down the data so that you don't make any mistakes. Be very specific and use only facts that you can prove. So, now you need to go and make sure you stand in the same spot each time. Use the ruler or a tape measure to measure from where you stood to the tip of the airplane of where it landed. You will need to do this for each airplane. Each airplane you will need to throw and measure 6 or more times. I wonder why you have to do that. Well, you can explain your data if you have multiple trials in the same experiment. So, let's find out why. How many times, so listen to this experiment, okay? If I said, how many times will a bouncy ball bounce when it's dropped from 3 feet in the air? Well, if I only did it once and it bounced twice, and then I did it again and it bounced 5 times, and I stopped, well, does it normally bounce twice or 5 times? Like, what is the main time it bounces? So we're going to have that same concept, and we're going to do that for our paper airplanes. Okay? Remember, you're keeping everything the same in the room. Okay? Then you're going to I would label your airplanes. Like I would do letters or red airplane if you put like a red dot. However you want to name your airplanes, just make sure they're all different, the name. And you can say like, okay, I did letter A. Trial A, airplane. Number of feet flown. So the first time I flew it, it flew 4 feet. The next time I flew it, kind of nosedived, 6 inches. And then the third time, the fourth time, the fifth time, and the sixth time. Conducting multiple trials is so important because the more you test each paper airplane, the better your results will be. All right? And so you're going to do this for every single airplane. So if you choose the magic number 6, you need to have 6 trials for every airplane. If you choose the number 10, remember, it's best 6 or above. If you choose 10, you're going to throw every airplane 10 times and write down the data, how far it flew, every single time you threw it. And keep all of this in your notebook. I'm super excited to see what your results are. In the next lesson, we're going to learn what to do with that data that we collected. Now, we are not going to have a science lesson tomorrow because I want you to take your time, and if you have to repeat this procedure, then I want you to do that so that you have correct data. Okay, so you're going to have today and tomorrow to get your experiment done and record your data, meaning how far did each airplane fly each time you threw it. All right, well, have fun. And I cannot wait to see it. And the other thing too is take pictures while you're doing this, or have somebody videotape you throwing your paper airplane a couple of times. All right, have fun.